Hello everyone, today we're gonna start exercise 6.2 from unit 6th Trigonometry and Bearings. In the first question, we need to find the length of arc and the area of sector for the given radius and the central angle. But before starting these questions, there is an important point that we need to keep in mind, and that is the formulas. The length of arc, it is denoted by L, and the value of L is equal to r theta, where r is the radius and the theta is the central angle which is given in the radian measure. And then we have the area of sector that is denoted by capital A, and that is equal to 1 by 2 r square theta. Okay, so now let's start with these questions with the first part where the radius is 5 and the theta is pi by 3 radians. So let's write the given data first. Our radius is 5 centimeter and the theta, which is the measure of the radian, that is pi by 3 radians. So let's write that here. And what do we need to find? We need to find the length of arc and the area of sector. So the length is equal to r theta. So the L will be equal to r, which is 5, multiplied by pi over 3. And the answer will be in centimeter because that is the unit of radius. So we can write L is equal to 5 pi divided by 3. So 5 will be multiplied by pi and then it will be divided by 3. So here we have 5.23 and that is our length. Okay, but we aren't done here. We also need to find the area of sector, which is equal to A 1 by 2 r square theta. So we're gonna write 1 by 2 as it is here. But instead of r square, we're gonna write 5 square. And instead of theta, we're gonna write pi over 3. Okay, now what is gonna happen? 5 5s are 25. So we can write 1 by 2 multiply 25 multiply pi over 3. So 3 2s are 6. So that means 25 will be multiplied by pi and divided by 6. So we can write 25 multiplied by the value of pi and then it is divided by 6. So we get 13.08. So 13.08 centimeter square will be our answer. Okay. Now in the second part, here the radius is in 12 meter. So we do not need to convert this into centimeter or any other unit. Just write it as it is and use the formula. So here the value of radius is 12 and the theta is in degree. So if the theta is in degree, as we learned in the previous lectures, if we need to convert it into radian, so that will be multiplied by pi by 180. So let's write the given data which we are given at first. What is the radius? We can write the radius as 12 meter and then our theta is given in 120 degree. So in order to convert this, we're gonna multiply that with pi over 180 degrees. So let's go to our calculator and then 120 will be multiplied by the value of pi and then we're gonna divide that with 180. After dividing that, we have 2.094. So our radius is 12 meter, but our theta is 2.094 and that too radians. So now what are we gonna do? We're gonna find the length, which is equal to r theta. So the length will be equal to 12 multiply 2.094. So let's multiply 12 with 2.094. So that is 25.128. So the length is equal to 25.128 meters. So this will be our answer for the length. But if we need to find the area of sector by using the formula 1 by 2 r square theta, firstly, what is r? That is 12. So we can write 1 by 2 multiplied by 12 whole square multiplied by the value of theta, which we just found, and that is 2.094. So we can write 2.094 here. Okay, what will happen now? Firstly, we will take the square of 12, which is 144. So 144 will be multiplied with 2.094 and then that value will be divided by 2. So we get 150.768. So our area will be equal to 150.768 and that to meter square, as that was the unit of the radius. Okay, now let's move on to the third part, which is the last part of question number 1. And here the radius is given in 6 dm, the theta is in the dms format. So firstly we're gonna convert the minute and the seconds into degree. We're gonna add them up, and then the degree will be converted into radian, and then we're just gonna apply the formula. So it's pretty easy. So let's write the value of the radius, which is 6 dm. After that we have theta, and what is theta here? 60 degree, 45 minute and 30 second. So 60 degree, 45 minute and 30 seconds. Okay, so let's convert this. 60 degree will be written as the same, while 45 will be multiplied by 160 whole theta. After that, what will happen? Then this 30 will be multiplied by 1 over 3600, because we're gonna multiply it both times. So instead of doing that and writing multiple steps, I'm just gonna divide this or multiply this with 1 by 3600. So this will be degree. So 60 degree will be added with whatever the output is of 45 multiply 1 by 60. So let's write it here. 45 divided by 60, that is 0.75. So 0.75 degree will be written here. After that 30 will be divided with 3600. So that is 0.008, 0.008 degree. Now all of these are gonna add up with each other. So we can write 60 plus 0.75 plus 0.008. So we get 60.758, 60.758 degree. Now this will be multiplied with what? It will be multiplied by pi over 180 to convert this into radian. So we can write this value, multiply the value with pi, and then divide that with 180. So we get 1.060. So 1.060 radian is equal to what? This is equal to our theta. So we got our theta, and then let's write the radius again, so just we do not have to scroll up. So this is our radius, and now we're gonna find the length. So the length is equal to r theta, whereas the value of r is 6, so we can just write 6 into 1.060. So what will be our answer? Let's just multiply 6 with 1.060. So we get 6.36. So the length is 6.36 dm. Okay, after that now we're gonna find the area of sector, which is 1 by 2 r square theta. So area will be equal to 1 by 2 r, we have 6, so 6 square multiply by what? That will be our theta. So our theta is 1.060. Okay, now what will happen? We will take the square of 6, which is 36. Now 36 will be multiplied with 1.060. After being multiplied, it will be divided by 2. So we get 19.08. So area is equal to 19.08 dm square as our final answer. Okay, now let's move on to question number 2. Here it states that a central angle in a circle of radius 4 centimeter is 75 degree. We need to find the length of the intercepted arc and the area bounded by the sector. So what given details are we having? Firstly, we have the radius, which is 4 centimeter, and then we are given the theta, and the theta is in degree, which is 75 degree. So what can we find? We need to find the length, and then we need to find the area. So we're gonna do the same stuff, but before doing and applying the formula, we're gonna convert the 75 degree into radian measure. So let's write that. I'm gonna scroll down and let's write the values for our question. Here we have radius as 4 centimeter, then our theta as 75 degree. Okay, so this 75 will be multiplied by pi over 180. That means that we are gonna first multiply 75 with pi and then divide that with 180. So we get 1.30. So that is equal to 1.30 radian. So let's write that here. After writing that, what will happen is that this will be multiplied by 4. So r theta, the value of r is 4 multiplied by the value of theta, which is 1.30. So what does this result in? 4 multiply 1.30, that is 5.2. So we can write L is equal to 5.2 and this will be centimeter. Now we will find the area. So in order to find the area, we're going to use the formula 1 by 2 r square theta. So we can write here 1 by 2, and what is r here? R is given as 4, so 4 square, and the value of theta is given as 1.30. So we can just write that here, and then we're gonna take the square of 4, which is 16. So 16 will be multiplied with 1.30. Here we get 20.8 divided by 2. So that means that area is equal to 10.4, and that 2 centimeter square. So that is the answer. Now in question number 3, we need to find the radian measure of the central angle of a circular circle of the following data. The length is given as 8 centimeter and the radius is given as 4. So what do we need to find? We need to find the theta. Let's write the question here. What is the length? Length is given as 8 centimeter, and then we are given the radius, which is 4 centimeter. So we can write L is equal to r theta. Now L will be equal to what? This will be equal to 4, and the theta will be just written as theta, but instead of L we're gonna now write the value of 8. So I'm gonna erase the value and write 8 here. Now as we know, 4 will be divided on both sides, so theta will be equal to 2 because 4 2s are 8. So this is our answer of theta. Now in the second part, we have 8.5 meter and then the radius as 2.25 meter. So let's see how this works out. Okay, so firstly, L will be equal to 8.5 meter, and then what do we have here? The radius is equal to 2.25 meter. So we need to find the theta here. As we know, the L is equal to r theta, so we're gonna place the value of L, which is 8.5, then 2.25 theta. So 2.25 will be divided on both sides. These both get cancelled, so the theta will be 8.5 divided by 2.25. 8.5, let's divide that with 2.25. So we get 3.77. So we can write theta is equal to 3.77. And what will be our theta in? Will it be in radian? Yes, it will be in radian. So we can write radian. And in the above, we need to do that too. So we can just write the value of theta in radian. So the theta will be 2 and radian here. Okay. Now let's move on to the next part. Here the area is given as 45 centimeter square and the radius. So what do we need to find here? The theta. So this is pretty easy. Let's write the expression here. The value is given 10.70. Take the square and then we will divide this value by 2. So what is the square of 10.70? The square of 10.70 is 114. So 114.49 will be divided by 2. So that results in 57.245. So 45 is equal to 57.245 degree. Now 57.245 degree will be divided on both sides. After it is divided on both sides, the value of theta, what will it be? We can just write 45 divided by 57.245. So we get 0.786. So 0.786 radian is our answer. Okay, then in the last part, this is quite tricky. We are given the area and the length. So we aren't given the radius, we aren't given the theta. So how are we going to solve this? So let's write the given data and then I'm going to show you. Okay, so first we are given the area, which is 100 centimeter square, and then we are given the length. Now what is the length? The length is 10 centimeter, and we need to find the theta. So in order to find the theta, let's look at the formula of the area. What is it? It is 1 by 2 r square theta. Now r square theta, this can be expanded. So we can write 1 by 2 r square theta as 1 by 2 r into r theta. And what is r theta equal to? That is equal to 10. So instead of r theta, we can write a is equal to 1 by 2 r into 10. So now 10 will be divided by 2, so that results in 5. So area is equal to 5r. And what was the value of area given? That was 100. So this is 5r. Now 5 will be divided on both sides to find the value of the radius. So 5 ones are 5, 5 twos are 10. So this means that radius is equal to 20 centimeter. Now when we get the value of 20 centimeter as a radius, we can just use our second formula, which is L is equal to r theta. So what will happen now? We're gonna write the value of L. So what was L? L was given as 10, that is equal to 20 theta. So 20 will be divided on both sides of the equation and the value of theta will be given. So let's divide 10 divided by 20. So that is 1 by 2 or 0.5. So that is 0.5. So we can write 1 by 2 or 0.5, and that too in radian. So this is the answer. Now in the question 4, we are given that we need to find the radius of circle for the following information. So here we are given the length of the circle, which is 4 centimeter, and then we are given the theta, which is pi radians. So what is pi radians equal to? Pi radians is equal to 180 degree. Okay, so this will be multiplied with the value of 4, and then we're gonna find the radius. Let's see how this works out. Okay, so first let's write the values. The length is equal to 4 centimeter, and then the theta is equal to pi radians. So what does this mean? This means that the L is equal to r theta, and what will happen is that this will be 4 and this will be r and this will be pi. So pi will be divided on both sides. So pi divided by 4 divided by pi, that will be equal to our radius. So let's write this. We are gonna divide 4 with pi, so that is 1.273. So we're gonna write 1.273 centimeter as our answer. So this is our answer. And then in the second part, we have 6 meter and the theta is in 15 degree. So this 15 degree, you should always know that the theta is in radian measure. That means that it will never be in degree. If it is in degree, that you need to convert it. So how are we going to solve this question? So here we have 15. So 15, if we have a value which is in degree and we want to convert it into radian, it will be multiplied by pi over 180. So let's write this 15 into pi, and this will be divided by 180. So this is 0.261. So 0.261 is our theta. So let's scroll below. We can just write theta is equal to 0.261, and then now this is in radian, and then we have the length, and the length is given as 6 meter. So length is equal to r theta. What is the length? 6. What is the radius? Not given, and the theta is 0.261. So the 0.261 will be divided on both sides. So that means r is equal to 6 divided by 0.261. So that results in 22.988, and the unit will be meters. So this is our answer. Okay, and then we have in the third part, the area and the theta given by pi by 4 radians. Now what is pi by 4 radians? If you divide the value of pi and 4, then you will just have that value of theta, and then we're going to use it in our formula. Okay, so let's see how this works out. Here the area is equal to 200 centimeters square. After that the theta is equal to pi by 4 radians. Okay, so pi by 4. What is pi by 4? If we divide the value of pi with 4, we get 0.78. So the theta is 0.78 radians. And our area will just be the same, which is 200 centimeter square. So how can we solve this? The area is equal to 1 by 2 r square theta. So if we write the value of area, which is 200, this will be equal to 1 by 2, and what is the value of r? That is not given, so we can just write this as it is, and the theta is 0.78. So now what will happen is that this 0.78 will be divided by 2, so we get 0.39. So we're gonna write 200, which is equal to 0.39 r square. Now 0.39 will be divided on both sides, and the value of r square will be 200 divided by 0.39. So this is 512. So we can write 512, but this is the value of r square, so we're gonna take square root on both the sides, and r will be equal to the square root of 512. So we're gonna use the sign of square root, and we're gonna take the square root of 512. So that is 22.627. So we can write 22.627, and what will the unit be? That will be centimeter. So this is our answer. Okay, now let's move on to the last part of question number 4. Here we have the area and then we have the length. Now what do we need to find? We need to find the radius. But if we need to find the radius but we aren't even given the theta or the radius, how are we going to do so? This is exactly the same as question number 3 and the last part. So we're going to follow the same steps that we did here and apply that here. So it is pretty easy. Now let's write the given data. Here the value of area is 100 dm square, while the value of the length is equal to 10 dm. Okay, so now as we know that area is equal to 1 by 2 r square theta, this can be expanded and we can write 1 by 2 r into r theta. So what will happen is that 1 by 2 will be written as it is, r will be written as it is, but instead of r theta we're gonna write 10, because r theta is equal to L, and what is the value of L? That is 10. And what is the value of A? That is 100. So 100 will be 10 by 2 r. So what will happen now? 10 divided by 2 is 5, so 100 will be equal to 5r, and we will get the value of r as 20. So this is our radius that we just found. So this is pretty easy. And what will be the unit? The unit will be dm. Okay, now let's move on to the last question of the exercise, which is question number 5. Here, a 30-inch pendulum. It swings through an angle of 30 degree. The theta is 30. Now we need to find the length of arc and then in inches through which the tip of the pendulum swings. The 30-inch pendulum is our radius and this angle is our theta. So what can we do? We will just write the given data we have. So I'm gonna write here that the radius is equal to 30 inches, and then the theta is equal to 30 degree. So what do we need to find? We need to find the length, which is r theta, while the 30 degree here, which is in theta, it's going to be converted into radians. So this will be multiplied by pi over 180. So let's convert that first. So we are going to write 30 multiplied by a value of pi first, and then it's going to be divided by 180. So that results in 0.52. So 0.52 radian is going to be written here. So L is equal to r theta, what is the value of the length? The value of the length is not given, but the radius is 30. This will be multiplied by 0.52. 0.52 multiplied by 30. So we get 15.6. So the length is 15.6 inches.